Welcome to my video. Today I'll be doing question 9 from past year paper IGCSE 060622 October-November 2018. The diagram shows part of the curve y equals to 2 square root of x and the normal to the curve at the point A 4 where x equals to 4 and y equals to 4 meets the x-axis at point B. So we need to be careful that we are looking for normal in this case, and usually we have gradients. We need to find gradients for tangents in some of the cases where the gradient of tangent is exactly the same as the gradient of the curve at this point. But since we are looking for the gradient of the normal, all we have to do is to know this rule, this specific rule where the gradient of tangent and normal multiply, you give you -1. So by knowing your tangent, you will be able to find your normal, and usually if they give you the normal, you will be able to find the tangent as well. So we move on to solving the first part of this question. Find the equation of the line AB. So when you look at the line AB here, so obviously this is a straight line. So when we know this is a straight line, it's a linear equation form. Is in linear equation form. So usually this is what we will be looking for. We need to find M and C in order to complete this question to give the complete answer for the equation of AB. And usually the M here will be, and in this case the M here will be the gradient of normal at this point for these coordinates. And of course, to find the gradient of normal, we will make use of the curve, the equation of the curve that they give us, where we will first be able to find, we can write the curve in this form as well if you prefer, but it doesn't matter, it's up to you. We'll definitely first have to find its dy dx, where we'll be actually start looking for its gradient of the curve at this particular point 4. And when you differentiate your curve, I prefer to write it in this form because all you have to do is to minus the degree by 1. In this case, become -1/2, and move the 1/2 down to the front over here. So in the end, this is my calculated differentiated equation over here. All I have to do is to sub in the coordinate here to find its gradient at this point. So I find that the gradient of the curve at that point is equals to 1/2. And notice that this is not exactly equals to the M of the AB equation here, because AB is the normal to this curve. So since this is the gradient, you'll notice that it's good to write down that this is gradient, always the gradient of the tangent as well as the curve at this point. So let's say if AB is tangent to the curve, then this would directly equals to the M over here, the gradient of AB, but in this case it's not. So you have to make use of this equation where you substitute 1/2 into the M2 over here, the gradient of tangent, to find is the gradient of normal. So all you have to do is to sub in your 1/2 into the M, and then you'll be able to find your final gradient for on the line AB, for the line AB, and you will get -2. And then after we find the gradient for the line AB, we'll be able to find its intersection C by making use of this coordinate 4, because at point 4 is basically giving you this point, is basically telling you that its x is equals to 4 and y is equals to 4. All you have to do is to sub in this numerical value into this formula. So y equals to 4, x equals to 4, we get our gradient of normal from here, which is -2, and all we have to do is to find C. Hence, you may use a calculator or just calculate mentally. You'll be able to find C equals to 12. And of course, your final answer will be you replacing all this M and C with the numerical one that you find over here. And this will be the gradient for your AB, the line of equation, the equation of the line. After this, you have to find the coordinates of B, which is the second part of this question. So since you have found the equation of the line AB, all you have to do is to first understand or to first notice that B is exactly on the x-axis, and all the coordinates of x-axis, their y-coordinates is equals to 0. So this is only a 1 mark question, so all you have to do is to substitute your y as 0 and find your x using the equation that you have found in your first part. And this is the answer that I found, where x equals to 6. And hence you may rewrite your B coordinate in this coordinate form. Then we move on to the last part of this question. Show all your working, find the area of the shaded region that gives you 4 marks. So to begin with, we look back at the diagram over here, where the shaded regions is everything is shaded over here for you. So all you have to do is to try see if you can divide the regions into shapes that you can calculate from. So usually I will divide it like this, where the points they give you on the curve, you will just draw a straight line, vertical straight line down from the point to its x-axis. Because we know that integration will help you find the area under the curve. So on this curve, by drawing the straight line down from the point given, I will be able to find all the areas under here using integration. And since we have a straight lines over here, with these 3 straight lines together, they form a right angle triangle over here. And I would like to label the point where the line that is drawn from the point down to the x-axis here as point C. So this is my way of separating the regions into this way, which help me with finding my area under the curve. Okay, so we move back to the third part of this question, where of course I will find the easiest one first. I will first find the area of triangle ABC, where the coordinates of C is 4, 0, A is 4, 4, B is 6, 0. If you look back at the diagram over here, the B, notice that we are given the coordinate A, and the coordinate B was found in part 2. So all we have to do is to write down the coordinate that we find in part 2. And how do we get coordinate C? So notice that C and B are on the same horizontal line, and that's the x-axis. So in another word, for C, its y coordinate is also 0. So what about its x coordinate? The x coordinate, as you can see, is also on the same vertical line of A as well, where the x coordinate for A is 4. In another word, the x coordinate for C is also 4. You may pause and look at the diagram to see if you'll be able to find C. You don't need further calculation. All you have to look at is your coordinate B and your coordinate A to deduct your coordinate C. And that will help you to find the triangle ABC, this right angle triangle, where the formula for finding the area of the triangle will be your height, let's label it A, times your base, let's label it small b, and divide by 2. So I might as well just write down over here. So area of triangle is, just in case you don't remember, it's best to memorize it. So it's half times its height multiplied by its base. Okay, so what's the height of this triangle over here? So the height of this triangle is obviously the distance between A and C, and in this case we look at the coordinates. A is 4, 4, C is 4, 0, so obviously A will be equals to 4. And what is base? Base is, we look at the x coordinates in this case, whereas for the x coordinate of C is 4, the x coordinate for B is 6, so B is equals to 6 minus 4, and that's equals to 2. So with all this information that we can find on this diagram, we can go back to our third part over here, where using the formula to find the triangle, find the area of the any triangle, you use the base times the height and multiply by 1/2, where we get 4. So this will be your first step in finding part of the area of this shaded region. And of course, the remaining area under the curve from origin to 4, 4, the given point 4, 4, will means all the area that is shaded under here, excluding the right angle triangle over here. So it's pretty straightforward. All you have to do is to integrate the formula of this curve and insert your value of 4 and insert the numerical value, like from which point to which point at the side over here. So it's from origin. Origin is means 0, 0 to 4, 4. In another word, we look at the x coordinate. So it's in another word 0 to 4. Just write it down, and then you integrate whatever is. You integrate the formula of the curve here. You may check your integration whether you have integrated correctly. Where to integrate, all you have to do is plus 1, you power into plus 1, in this case become 3/2, and then you put your 3/2 at the bottom of the entire expression here. In other words, you divide them by 3/2, and then you simplify your equation over here first before you substitute your numerical values into the x. So after I simplify it, I substitute it. Since everything multiplied by 0 is nothing, is equals to 0, so in the end, this is the only part we have to worry about. So press your calculator, you'll be able to find the 2/3. But do not forget, this is only the area under the curve from origin to 4, 4. We need to plus 4 as well. So to find the total shaded area under in the diagram. So after we plus 4, you'll be able to find 44/3, and then you can put it in decimal places as well, where you'll get a recurring decimals here, but you can round it up to 14.4. Either of them will give you full marks. Okay, so this is all you have to write down to get your full marks in this question.